Hi, everybody. This is Marie Tipton. I'm the education coordinator at the Tijuana River National Estuary and Research Reserve. And we're going to start in 1 minute. Let me share my screen. And here we go. Okie dokie. Hi, everybody. Do we have some people joining us, Mara and Lorena? You have about 1 minute still. Hi, everybody. I'm Marie Tipton. I'm the education coordinator at the Tijuana River National Estuary and Research Reserve. Welcome to the virtual King Tide tour. I'm going to be starting momentarily, and I'll give you an introduction in a minute. But thank you for joining us, and I'm so glad you're with us today. Hope you're staying warm. The last couple of days have been kind of chilly. And we have our environmental scientist, Lorena Warnalara, with us, and one of our educators, Marie Ahmad, who will be, oh, here it is, 12 o'clock. So welcome everybody to the King Tide virtual tour. I'm Marie Tipton. I'm the education coordinator at the Tijuana River National Estuary and Research Reserve. And we normally do this tour in person, and I wish we could do that because we get a lot of you folks coming to seeing it live, but we want to do this today because the next set of King Tides is Sunday through Tuesday. So that's why we're doing this today. And welcome, I'm glad you're with me. And I wanted to let you know that please put your questions in the chat on Facebook, and Maria Ahmad, educator here, and Lorena Warnalara, our environmental scientist, will be monitoring the chat, and we go ahead and just write in your questions along the way. I'm happy to get questions throughout this presentation. This presentation is going to be about an hour long, and just if you can't make us all the way through, I want to let you know that this will be archived on our Facebook page, and I believe we will be saving it to the YouTube channel as well. So thank you very much. And here we go. Here we go. So this is a gorgeous photo from our sister reserve up in San Francisco Bay. This is a poem by Howard Shellhammer. It's called Civil Twilights in the Marsh. Civil twilight is a sterile term for the time of glowing sky, quiet water, ducks floating, terns squawking overhead, geese rising from the marsh. Man's imprint is everywhere, dikes, ponds, and power lines, the roar from distant freeways. But there is so much here of nature's beauty primeval. Here you can experience peace and imagine eternity as the sun breaks or sets over the distant purple hills. Isn't that gorgeous? And I'm sure many of you have seen the sunsets over the Tijuana Estuary, which are gorgeous too. Here, I wanted to let you because I'm going to be talking about local King Tide issues and then studies that go across the whole research reserve system. So I wanted to show you this map. This is the map of the National Estuary and Research Reserve whole system. It's a network of 29 protected areas established for long-term research, education, and stewardship. You'll see that there's a lot of reserves on the East Coast, and there's some in the Gulf of Mexico. The West Coast, there's also Alaska and Hawaii, and Hobos Bay down in Puerto Rico. So this is a large system, and we're actually going to be probably having Connecticut join us soon. And the Great Lakes reserves are more, they don't have salt water, of course, but they're, I guess what you would say is freshwater estuaries. So today I want to talk about how you can be part of this citizen science or community science project, the California King Tides, and I want to go over what it is, and then towards the end I'll talk about how you can participate in it and get ready to go. The high tide on Sunday is 7:25. So if you're an early riser, you can be out there on Sunday. So California King Tide Project is, the purpose of it is to document current flood risk in coastal areas, to visualize the impacts of future sea level rise in their community, to ground truth and validate climate change models by comparing model predictions with the high tide reality, and to serve as a living record of change for future generations. So your photos, I'm going to show you towards the end, there's a photo of Seacoast Drive that's actually in the gallery on the California King Tide Project that you could look at. So because we're not in person, unfortunately, I wanted to show you some snapshots that we took of king tides in the reserve. Here is the northwest corner of the reserve, the most intact part of the marsh. You could see we're at the corner of Imperial Beach Boulevard and Seacoast, and that wooden structure is held a raw sewage pipe that piped sewage into the marsh up until about the 1930s or 40s. So this is the corner where we do our field trip for elementary students and everything, and we do our Marsh Secrets Ports program. So this is a pretty high tide, and so when we have a king tide, a good high king tide, and especially if it's associated with El Nino, which makes the warming ocean makes the water molecules expand, so it's called thermal expansion. So when we have an El Nino and these king tides, we can get really high tides. But this is a pretty high tide, and you can see that the marsh looks more like a bay. Here's a familiar picture for many of you that live in Imperial Beach and have been down during the king tides. Here's a picture at the south end of Seacoast Drive, and most of this water is coming in from the coast, from when there's really high tides, and when the tides actually sweep over the berm that they have there, and it gets back into here. And last year we had quite a lot of sand that got put into the marsh, that was washed into the marsh. So the marsh is there to your right, and that you can see that the marsh is really full of water as well. So this is a pretty high tide day. Here is looking southeast towards Mexico and towards the east. So this is a really neat picture with the beautiful clouds reflecting on the water. Again, this is the marsh. So this is the marsh that normally in the lower tide you would see vegetation. So in the middle of the slide is the Navy outlying landing field and the south end of 5th Street down there. So this is just showing you how the king tides can totally transform the marsh, and it's a great time to visit the reserve and make your snapshots. Here is a snapshot of the tidal linkage, which is our first restoration project that connected the two parts of the marsh. And look at this. Those of you who come to the marsh a lot, you'll notice this is really, really high tide. So this is probably another 7-something foot tide, and it makes the channel look a lot huger than it normally does on maybe like a 3-foot tide. So you can see there's vegetation underneath a lot of that water, but and you can see the visitor center right there to your right. So just wanted to give you, absorb some king tide phenomena so that it'll entice you to come out there starting on Sunday. Okay, so what is a king tide? So you probably heard the term king tide, but you may not know what it is. A king tide are the highest tides of the year, occurring when the sun and the moon are in alignment and closer to the earth. So you'll notice, like here's in this diagram, we have in January, there's only 147 million kilometers from the moon to the sun. But then in July, the sun is 152 million kilometers away. So the tides, many people know that the tides are influenced by the gravitational pull of the moon, but not a lot of people know that it's actually also influenced by the sun. So let me show you this right here. So a king tide is what's called a perigean spring tide. Like I was saying before, perigean means that the moon and the sun are closer than normal. I mean, closer to in that time of year. And I'll show you what a spring tide is in the next slide. So a king tide, the technical term is king tide is just a nickname. The technical term is perigean spring tide. All right, so here is an image that really shows you what's happening. This is a spring tide, and this is if you notice, the sun is shining on the moon, so that this would be when the sun is shining on the moon like this, that means we see it as a full moon. And you notice that the bulge from the sun is the yellowy orange part, so that influences, and then additive to that is the bulge from the moon, and then we get a total bulge from the sun and the moon. And that's how we get the really, really high tides. So like we're gonna get, like this upcoming tides are gonna be between 7.4 and 7.5 feet. So that's gonna be a pretty high tide. So let me show you what a neap tide. So there's spring tides and then there's neap, N-E-A-P, neap tides. And you'll notice that the sun and the moon are more at angles with each other. So it's not an additive influence. So the bulge from the sun is one way and the bulge from the moon is another way. So when it's high, so this would be a quarter moon probably. So when we have either a new moon, which is where we can't really see the moon, or a full moon, that's when we get the spring tides. And the neap tides are when that situation isn't happening. Here's another picture of a spring tide. This is when we have a new moon. So we have a new moon when the sun is shining on the back side of the moon, but you can see here that the bulges are additive. Again, the tidal bulge from the sun, the tidal bulge from the moon are additive to make a large tide. And then the next slide is another neap tide with just the moon on the other side. So there you can see that the moon's monthly orbit is elliptical, it's called. It's more like an oval, it's not round. And then there's the Earth. There's another, you can see the arrow that shows the Earth's yearly orbit around the sun as well. So here we go.
Anne Marie, before
yes.
you move on to the weather station, while you're
yes.
talking about tides, there's a question from Peacock, and I also put it in the chat for you.
Yeah, so I can't read the chat very well, so it's better if you tell it to me out loud.
So the question is, how far behind the tide table times for San Diego coast is the tidal high at the southern end of San Diego Bay? So I think she's referring to the lag time.
Yeah, how long? I don't know about the southern end of San Diego Bay, but I do know the northern part of the marsh, which is what I showed in an earlier slide and what's on the opposite side of this weather station. So it normally takes about an hour for the tide to make it from the mouth of the Tijuana River, which is where the river meets the sea at the south end of Seacoast, and then down at the end of the dunes. When the tide comes in, it takes about an hour for the tides to make it to the northern part of the marsh, which is right here by the visitor center. So I do know that, but I'm not quite sure about the south end of the bay, but I could find out, so I'll look into it. So thank you for that question. Any other questions?
No, not at this time, just some hellos from a few of our Facebook fans and some of our volunteers.
Oh, great.
Yeah.
Thank you for joining us, everybody. All right, so we're going to be talking about what's called the Sentinel Site program. in a minute, which is a National Estuary Research Reserve program that's related to monitoring sea level rise. But I wanted to show you a big part of the monitoring that we do that's related to Sentinel Sites as well. And I wanted to give you that. You could see in the parentheses is where you could get all this data. If you're really into data analysis and mining, you could actually look at this data yourself, and you could actually see what the tide's going to be looking like and what the weather is at the Tijuana Estuary all the time. So here's a photo of our weather station, and all the 29 research reserves have weather stations, or they're going to get a weather station, and the Hawaii Reserve is pretty new, so they're trying to get in all their stuff right now, but we've had this deployed for a while. This is a weather station that's just west of our visitor center, and you can see that we have what it monitors labeled. Here's the rain gauge, and which is like a little tipping bucket that measures precipitation. There's the wind vane that measures the wind direction. There's the anemometer, which is like that little propeller looking thing that measures the wind speed. Then we have temperature and humidity on that little stack thing. We also have a barometer that measures the atmospheric pressure. The thing that looks like a gray top hat right here in the middle is an antenna. That's why this station is relatively real time. It goes into a satellite and gets uploaded to a satellite. And then PAR is photosynthetically active radiation. That is radiation that's relevant to plants and relevant to photosynthesis, which is how plants make their own food. So these are the parameters that are measured every day, all the time by the weather station. And you can go on your cell phone right now to nersdata.org/mobile, scroll down to what it says TJ Met, MET for meteorological, and you can see what the weather is right now at the reserve. I bet you it's pretty chilly out there. So that's our weather station. And I wanted to let you know the difference between weather and climate. So here's our metaphor, heat trapping blanket, but weather, I would say it's kind of like, well, if you want to think of it an analogy to a closet. So weather is what you're going to wear today. Like I'm wearing my long sleeve uniform because it's pretty chilly in my house. And so that's what I would wear. But the climate is all the clothes that I have in my closet. So the climate in an area, like we have a Mediterranean climate where it mostly rains in the wintertime, and it doesn't really get too cold. So the climate in an area is the long-term trend of what's happening, and the weather is what's happening now. So, but when you talk about sea level rise and king tides, you need to talk about climate change. And one of the main metaphors we like to use is thinking of the heat trapping blanket and carbon dioxide, and whether it's regular or rampant carbon dioxide. So normally we need to have carbon dioxide in our atmosphere to create a blanket, a normal kind of blanket, because that's how we could live on this planet. Otherwise it'd get way too cold. So you can see what's happening here is heat from the sun radiates off the Earth's surface, and some escapes the Earth's atmosphere, but the rest of it is trapped, and that's how we get the warmth from the sun. So, but then what happens is since the Industrial Revolution, we've been releasing coal and natural gas, and also through animal agriculture. In agriculture, we release methane and nitrous oxide, and some of the heat is trapped by gases in the atmosphere, and these gases act like a heat trapping blanket holding in the Earth's heat. And then as humans burn more fossil fuels, there's more CO2 in the atmosphere, which holds in more of the Earth's heat, and this contributes to a warming Earth. So that's what we call rampant CO2. And the CO2 in parts per million is way over 400, and we want to get it down to lower than 350. So we need to keep fossil fuels in the ground, and hopefully we are moving in that direction. So that's what a heat trapping blanket is. That's what causes climate change. And so what happens is, and unfortunately, a lot of that heat gets absorbed into the ocean, and then also the extra CO2 impacts the ocean as well through the acidification. So what's interesting about being part of a system is we have the Sentinel Site system, which is, and the goal of the Sentinel Site cooperatives is to increase awareness of the effects of sea level rise and identify appropriate steps for communities to take in order to minimize the impact. And the elements that make up a Sentinel Site include a surface elevation table, which I'll be talking about soon, the vertical reference system, so that's talking about how the elevation goes up and down, the data loggers, which I'll talk about a little later, the weather station, which I just showed you, vegetation transects, which are co-located with the surface elevation tables. So we do vegetation sampling a couple times a year. And we are sampling what species are happening at what elevation in the marsh, because there's generally different species in the low marsh versus middle marsh and high marsh. Habitat maps, which we are doing with our geographic information system person, Monica Almeida. We have elevation surveys, digital elevation model, and like a digital topo map. So with LiDAR, which is a way that we could actually do fine topo maps, which are topography maps of the marsh. Now, it doesn't take a lot to, our marsh isn't very steep, and our tidal range isn't very big either, but compared to some places like Alaska. But those are the elements of what's called the Sentinel Site program. And so let's talk about the surface elevation tables first. So this is a little soil core, and that white part is the feldspar marker. So feldspar is a mineral, and it's put in on top of the sediment in a salt marsh. So what's happening is, so at where we have our surface elevation tables, which were installed by the US Geological Survey people in 2012, you put down a feldspar marker, and then you do monitoring every so often to measure what's called the vertical accretion. So let me show you that. Let me show you this. This is called a marker horizon. And then here's a live root zone. I'll talk about those roots in a little bit later when we talk about carbon sequestration. So here's the vertical accretion, and this is how we measure the buildup of sediment. And the buildup of sediment is really, really important for how we can adapt to, or how we can be resilient to sea level rise. And I'll be talking about what our measurements are a little bit later when I talk about a study that was done back in 2016. So here's how it's set up, and then I'll show you what it looks like. There's some small little tubes that go into it, and that's how we measure the elevation change. And then so we measure elevation change of the marsh, and we're also measuring the vertical accretion or built up of sediment. So here's a picture of Justin McCullough, one of our research associates. He's out there in the marsh. It can be a kind of a little dirty thing, activity, but you can see he's setting up that thing that's going to measure the elevation. So those little tubes help to measure it in millimeters, the elevation change over time. You can see this is our own little device that's similar to the diagram that I showed you. So here's Justin measuring the surface elevation table, which is part of our Sentinel Site program. Are any questions about that? Because it's kind of a little bit technical about Sentinel Sites or the surface elevation tables. I'll just wait a little bit.
No, there's no questions.
Okay. If you have questions later, just go ahead and pop them up. Thank you. Okay, remember I told you I was going to talk about a study. So this is my partner. She's actually retired from the reserve, but Sarah Ferner up at San Francisco Bay NER. She also presented on this really important study. That's why it says China Camp State Park, San Francisco Bay. So these are her slides that she talked about a study that put together and looked at 16 marshes in the National Estuary Research Reserve System, indicates that they are facing challenges. So what's really interesting is Kenny Raposa, he's at the Rhode Island near Gansett Bay Research Reserve. He did this study and he included 15 other marshes, and you could see that what were they measuring? They were looking at marsh elevation, elevation change over time, the sediment supply, the tidal range. Remember I told you what is the range of the lowest low tide to the highest high tide, and sea level rise. So those are the measures. So this is a metric that they were putting together, and then the overall resilience is that right there. So green means it's okay, it's not super high, but it's not super low. So let me show you the next slide. This shows several of the reserves. So most of them are the East Coast. And so these are all the different reserves. And so again, how will the tidal marshes fare in the face of sea level rise? You can see we're here on the bottom. So yellow means not so great. Red reads really low resilience, and green means high resilience. So you can see when it comes to sediment supply, tidal range, we're a little bit getting towards the low side, but the marsh elevation is kind of okay. But one of the things that we did find out is that the accretion, vertical accretion of the sediment, that's the sediment supply, we're doing okay. So this project is called Marsh Resilience to Sea Level Rise, or MARS. So the MARS metrics for Tijuana River NER. And so, but the whole project it talks about how tidal marsh resilience to sea level rise can vary due to differences in local rates of sea level rise, coastal geomorphology, sediment availability, and other factors. Understanding differences in resilience is critical to inform coastal management and policy, but comparing resilience across marshes was hindered by a lack of simple, effective analysis tools until this study. So this was the first study that really did that, and what they did is they tried to make this available, and they published this paper so that other people that, like the National Estuary Program and other people that manage marshes, could have this data. So what we found out was since 2012, the rate of short-term accretion since then is 5.4 millimeters per year. And then, so that means that it was doing pretty well when the accretion was built up, because we have plenty of sediment supply. You probably know that because we have our sedimentation basins and everything. And so one thing is good is the short-term buildup of the sediment can currently keep up with sea level rise. One of the areas that was called skewness, which is related to an XY curve and a curve, is that our vegetation is susceptible to drowning. So a positive skewness is anything over 0. So we're close to 1. So 0.62 is getting on its way closer to 1. So we are susceptible to drowning the reserves. So we did some studies in the marsh too that showed that the upper marsh plants like pickleweed don't do very well when they're inundated. So we had a scientist plant low marsh plants like cordgrass up in the upper marsh, and then vice versa, things like pickleweed in the low marsh. And they did say that those species are susceptible to drowning and they don't like to be inundated. But we did find out that our Mars risk index is a 4 out of 5, and 5 is good. So that's good. So what that all means is a moderate Mars scores call for actions to enhance resilience, while low scores suggest investment may be better directed to adaptation strategies such as creating opportunities for marsh migration rather than attempting to save existing marshes. So the Northeast reserves that are up in Rhode Island and Massachusetts, for example, they have much lower Mars risk index numbers. So then that could inform coastal managers like the reserve managers and others to try to build marshes upland instead. So marsh migration is when marshes move inland or up an elevation. And so this is showing that they might have to actually abandon their existing marshes, but do some restoration in the upper area so that they can be more resilient to sea level rise. So this is a really important study that was done in 2016, and it really will help coastal managers. And I'll talk in a minute about our restoration project too, which is called TETRIP, or the Tijuana Estuary Tidal Restoration Program. So this is a really important study, and it really helps managers. And it sounds like really, really technical. If those of you it's only a 13-page report. So if anyone is interested in this study, we can make it available to you. Okay. I wanted to talk about what else have we done to see how vulnerable our salt marsh is. And we did a study called the Climate Understanding and Resilience in the River Valley Study, or CURVE. And what it is a vulnerability analysis with 4 possible futures that included not just sea level rise, but also included flooding. So this is a very important study. This is a cutting edge study that, instead of saying like we are going to do a model to find out what sea level rise level is going to be, we actually, a bunch of scientists came together and thought that it was better to look at 4 possible futures. And if you've ever been in the visitor center, at the end of the visitor center, we actually have some paintings that were done by we had our artist in residence who at the time was in high school, Audrey Carver, and I'm going to be showing you her watercolors, but then she did paintings on just this plywood that we have at the end of the visitor center that hopefully you could see sometime next year when hopefully we could open up again. Let me show you the 4 potential futures that were. So what was really interesting is this project of visualizing these futures it kind of blew the mind of the climate planner that we have, Danny Boudreau, who now works back at the National Estuary Research Reserve System, and all the other scientists, because they weren't used to like using art to visualize potential futures. And so this was a very good exercise for them to really think, and they worked a lot with Audrey on these visualizations. So we have 4 different types of futures. This first one is Lake Tijuana, and this is a situation where there's obviously a lot of riverine flooding. So this is a lot of fresh water. You can see the mallard down there. And so this is where the river mouth is closed, and there's a lot of fresh water coming in from the watershed. That's what Lake Tijuana is. So you can see it's changing from a salt marsh to a riparian woodland or a freshwater marsh. So this is a total type conversion of this habitat. The next one, the Marsh Madness potential feature, is more of what we have right now. There's some ridgeway rails down there at the bottom. This is where the river mouth is open. And we have issues with, if you know about the reserve, you know that we have issues with the river mouth because of the beach replenishment issues. But this is a situation where the river mouth keeps open like it is now, and it's pretty similar. And then the marsh is adapting to sea level rise. Okay, here is another one was called Salt of the Earth. This is when the marsh pretty much just dries out and we just have salt pan, and that can be good for species like the California least tern, as long as they could do some foraging in the ocean for their fish food. But this is a situation where the river mouth is closed, and this actually, something similar to this happened in the El Nino of 1983, where the river mouth was closed. We didn't have the Army Corps permits to open it up. And several of the salt marsh areas died. We lost a species of salt marsh plant. And there were, if you see the photo we've used a lot, there's big circles of salt pan and where the salt marsh has gone away. So that's that scenario. Another scenario is the sea around us. And that potential future is where it's more the Tijuana estuary is more like a bay. So the river mouth is open, and then there's a lot of sea level rise happening, but then it's not necessarily salt marsh. You can see it's a lot of dunes and things like that. So doing this kind of planning makes us more nimble, makes us more flexible. We can see there's might be certain things happening. We did an implementation plan where we, for all the coastal training program, which is the working with adult decision makers, the research program, the stewardship program, and the education program, all put together a plan for how we're going to adapt to these changes over time. So let's go back to talking about the data loggers. And any questions, guys?
There was a question about the about this being recorded and where it would be located, and I put our YouTube channel on our in the comments. So
yeah, and it's also going to be archived on our Facebook page too. So this will be available. Thank you for that question. So here's another part of our system-wide monitoring program, or SWAMP, which is the data loggers. So these are data sondes of data loggers. They're in the water. They're below all this kelp, the kelp on top of the data logger is a problem, so we have to clean that up a lot. So here's a photo of a data sonde or data logger where we have an instrument, which I'll show you in a minute, that monitors the water quality, and those are the physical parameters of the water. And I'll show you the parameters in a minute, but I want to go over what you're looking at. So up here is, up towards the top is the solar panel, which is how we get the power for the data logger. There's also a gray top hat looking antenna, which is what we have at the weather station. So this is at the south end of Seacoast Drive and 3/4 of the way down. So this is our real time. So if you go to nersdata.org/mobile and look at the water station, you could know what the water quality is right now, or pretty close. And so this is a way that you could remotely look at the water quality all the time, which is what's so amazing about our data, is always being available online. So this is what it looks like with the pole and everything. Let me show you what it looks like underneath. So this is a photo of the old style data sonde. Ours is a little bit skinnier and different color, but that doesn't really matter. So what happens is this is all electric. All these measurements these are probes that are at the bottom down there. Then they need to be taken in and out every couple of weeks to clean out. Sometimes we even had a octopus get stuck on the bottom of them. And sometimes barnacles start growing, so we got to take them off. So we're measuring, actually, this talks about depth. We actually are measuring level right now, which is, so we have actually connected it to sea level. This used to be relative depth, but now we actually figured it out, and our data sondes are actually connected to the real sea level. There's connectivity, that's the amount of salt in the water. There's the temperature of the water, chlorophyll level, dissolved oxygen. That's how much oxygen is in the water, which is really important for aquatic animals like fish who breathe through their gills and need that oxygen. And pH of the water, and turbidity. Turbidity is how cloudy or full of sediment the water is. So these are what the sondes look like. This is what the probes look like in the data sonde. And we have a couple of them deployed in, the Tijuana Estuary. We also have a couple deployed at the south end of the bay, the San Diego Bay, to help us measure what's happening with the restoration that the Fish and Wildlife Service did. So this is another part of the Sentinel Site program. I wanted to let you know about another digital resource. If there's any educators out there or even people who are curious, this is the Digital Coast. This is an image of China Camp State Park up at the San Francisco Bay National Estuary Research Reserve, showing you that you can use this to visualize what the marsh might look at. This is, you can see this is 1 foot of sea level rise. And you can visualize what the salt marsh will look like and how much it might be covered with water. So the NOAA Digital Coast is really, really good. And you can see the URL is coast.noaa.gov/sea level rise, or SLR. So the NOAA Digital Coast is a really great resource for climate planners, for researchers, for educators who are teaching about sea level rise. And this is a great resource for folks. So I talked about how we monitor and look for how resilient we are to sea level rise and riverine flooding. But I wanted to talk about the more encouraging solutions and how salt marshes are actually solutions to the rampant CO2 and to climate change. So the term is called blue carbon, and blue carbon is the carbon related to the ocean and to the marshes. And what you might be really surprised to learn is that salt marshes are the most effective plant community on the earth for carbon sequestration, are grabbing that carbon, and it grabs it at a rate of 210 grams of carbon per meter per year. So sequestration is how the plant, so all plants on the earth sequester carbon. They grab carbon out of the atmosphere through photosynthesis. So photosynthesis is CO2 plus H2O, or water, equals their sugars that they make. And then of course you need the sun shining on them. That's why we have photosynthetically active radiation measured in the weather station. So believe it or not, the salt marshes are more effective than any other plant community on the earth. And I'll tell you about why in a minute. The Tijuana Estuary salt marsh in the upper part of the marsh is 235 acres, which is like 1.5 times the Qualcomm or the SDCCU stadium, with a lot included. And when I did the math, we found out that the intact marsh here sequesters 200 metric tons a year. So to do some social math to get you to understand that, unfortunately here in the United States, the average family, their carbon calculator is about 20 metric tons a year. They actually emit, are responsible for emitting 20 metric tons a year just for their lifestyle. Now, places like, I took a massive online course and I found that some of our colleagues in Philippines, they only have 2 metric tons a year per person. And I think I figured it out, even though I'm vegan, and back when I was driving my little car that gets 31 miles per hour, my impact was 9 metric tons a year by myself. So that was kind of high. But our salt marsh grabs 200 metric tons a year. And we have, one of our solutions is restoration. And like I talked about before, so our program is called the Tijuana Estuary Tidal Restoration Program. And we're hoping to at least start with 80 acres eventually. It's very expensive restoration, but it could be up to 200 acres. And what's interesting about restoration in the salt marsh is its adaptation, which means getting ready for climate change, but it's also mitigation, which means it actually fights climate change. So that's what's so amazing about that, and that's why it's so important that we move forward with our Tetra project down at Borderfield State Park. So let me give you let me show you why we're so good at sequestering carbon. This is a really interesting diagram. This is carbon density in kilograms per meter squared. And the green part are plants, and the brown part is soil and where the carbon is. You'll notice here that peatlands are really important. They have a lot of carbon sequestered underground, but wetlands are really good too. So wetlands, you can see this big brown part. We have a lot of our carbon stored underground. That's why we're called a carbon sink, because carbon comes in and it hardly ever releases. And I'll show you how we compare to other plant communities, and again, why we're so good at sequestering. This is a paper, so this is pretty new science. This is 2011, about 9 years ago. This is pretty new science. So this is remember I was telling you the sequestration rate, the grams of carbon per square meter per year. So here's what you would think: tropical rainforest, temperate forest, obviously the redwood forests are so important, and things like that. But the boreal forests and tropical forests, look at their sequestration rate. It's so low. It's less than. This is I think it's not linear scale, but here's the mangroves and tidal marshes and seagrass meadows, which is at levels around 100 to 200 grams per year. So what's amazing about tidal marshes is that number one, a lot of the carbon is underground. Number two, they never burn. Number three, no one eats them and burps out methane when they eat them, like grasslands or something like that. And what's really great is that methane is a carbon atom, hydrogen, and so it's 4 hydrogen atoms and 1 carbon atom, CH4. Methane is a very potent heat trapping gas. It might be up to 30 times more potent than CO2. And what's amazing about tidal marshes is that the salt water impedes methane production. So the salt water, when plants break down, they release methane, and that's why it's so important not to have all the lands up in the Arctic to melt, because we don't want to melt the tundra, because then we're going to have methane production, because all that tundra is holding in so much carbon. And so that's why restoring salt marshes are so important, and protecting salt marshes, because they do so much carbon sequestration and just naturally, which is really great. And so this is information, like I said, that we'd only known in the last 9 years or so, and we call this blue carbon. So that's really neat. Here's a visualization. So after we finish tetrap down at Border Field, and let's say we got up to about 200 more acres, then it will sequester about 440 metric tons a year, or taking 113 Honda Civics off the road, according to my calculation. Look at all those Honda Civics. That's pretty good, just our little marsh. Our marsh is the largest coastal wetland in Southern California, but if you didn't know, we only have about 10% of wetlands left in California, because they were all developed. That's why it's so important to do more restoration and protection of this plant community, because it could help fight climate change. So I told you at the end that we would talk about the California King Tide Project. It's called, their slogan is snap the shore, see the future. And here's a photo up in San Francisco area, or Marin. Look at this, look at these guys. I don't know if you'd be driving through an area like that. That'd pretty much wreck your car. So this is a King Tide day, I think. And so the website for doing that is right here. It's coastal.ca.gov/King Tides. This is the website for how to participate in the photo monitoring project, how to upload your photos that you take. And I wanted to let you know, I didn't go over it very much, but Sunday, we have a 7.4 tide at 7:25. So like I said, if you are early riser, come on down. Monday, we have the highest tide is 7.5 feet at 8:05 a.m. So it's a little later. And Tuesday, we have a 7.4 at 8:47 a.m. So that's a little later. So maybe if you want to wait till Tuesday and see the king tide, come on down to the marsh or any of your local coastal areas. Take some photos. I wanted to show you this king tide photo gallery that's on the site. And here's all the different counties. And let me get you down. Hope we don't get dizzy, because we're down at the bottom because it's from north to south. Let's go down to San Diego County. We're here. We're coming. Orange County. Here we go. Does this look familiar, people? Look at Cortez Avenue at Seacoast Drive as an example of a king tide. I think I've seen this happen before. The water's coming in. That might even be last year. The water's coming in from the super high tides coming up over the dunes and coming into that area of Seacoast Drive. I've seen that happen quite a lot. Here's a photo of Torrey Pines State Beach. So here's some other photos. There's West Barfield Drive, looks like Mission Bay. Oh dear. So that's some examples of what's in the gallery. And I wanted to let you know that my colleague Aaron Gates with the Ports program, the Parks online resources for teachers and students, want to let everybody know that if you want to get hear a presentation on Monday, there's another Facebook live stream at 8:30 a.m. with the director and the resources secretary presenting live. We have a new director. He's a great guy, Armando Quintero, and he has a background in environmental education, which is amazing. And so usually these folks, you know, these upper level folks, they do a recording, right? They give us a recording, but these folks are going to be live. So if you want to see a broadcast that's live during the king tide situation up and down the coast, then go to the California State Parks Facebook page at 8:30 on Monday and hear from interpreters all up and down the coast, and also the director and resources secretary. So that should be fun. I wanted to give you some more resources underneath. Here's my name, Marie Tipton. I'm the education coordinator. And I also, here's my email. Here's our website. And here's the long, this is a similar nersdata.org. This is the long URL. It's cdmo.arug.sc.edu. What's neat about that, if there's any people that are interested in data or any educators, our weather station and our water quality data can be mapped. We have mapping applications that are very simple and easy to use. There's some tutorials that are available for that as well. And so if you want to look at sea level rise, if you want to graph sea level rise over time, the water level or the water depth, you can do that as well if you want to investigate those kind of things. So I'm done with my presentation. So this is a time where if you have any questions, I'll leave some time for questions. So thanks everybody for being involved with our virtual King Tide tour. I appreciate that.
All right, Anne-Marie, there are no questions at the moment, but there is definitely a delay.
Yes, so we'll wait.
There was a question, a little unrelated to tides, but about a species database. Is there like an all-inclusive species database for the Tijuana Estuary?
Well, there's the natural diversity database, which the California Department of Fish and Wildlife keeps, and that's a pretty good thing. We do have species list that you could email me about, and I can get that to you. We do have we have general species list that are available too.
Okay, great. We have,
Your fellow Anne Marie was watching the program, and she has some shout outs for you that you'll want to check out on Facebook.
Oh,
Marie Cox.
yeah, Emery Cox. Hello, Emery. Us Emery's got to stick together.
yeah, so no other questions, just a few thank yous and shout outs. There's quite a few links in the comment section. So those are there for your reference.
Good.
Anyone who's chiming in later.
Okay, yes. And this is going to be available on our Facebook page, and we're going to post it to the our YouTube channel as well. So this will be available. And I wanted to give a pitch for starting in January, where we have more opportunities for education, the ports programs. We have ports programs on Wednesday, Thursday, and Friday. And on Wednesday and Thursday, we have middle and high school programs that you could sign up for that are all about, it covers this exact information. We have Detecting a Changing Climate for high schoolers, and Can Salt Marshes Help Fight Climate Change for middle schoolers. So if there's any educators out there or that want to reserve a ports program, please do. And you can go to ports-ca.us and look for us and sign up.
Yeah, I also wanted to mention, Anne Marie, that I don't know if people realize, but the king tides, as Anne Marie mentioned, is a sort of a nickname, but it's the time of year when we have your most extreme tides. So not only do you have your highest highs, but you also have your lowest low tides, which means it's a great time to go tide pulling and take advantage of those opportunities here along the coast in San Diego.
That's true. That's true. And maybe the low tides be more towards the middle of the day.
Yeah,
That's
the high tide.
That's Sunday, high tides, 7:25. Woo! I'm not sure I'll be awake right then. But I know there's a lot of early risers on here.
Yeah, that's hopefully by then any frost that's on the ground has melted away.
Mm-hmm.
There's been frosts in the canyons, I know that.
Yep.
So it doesn't seem like we're getting any more comments, just a lot of thank yous.
Great.
For the program.
Cool. Well, you know how to find us. If you have any more questions, I hope you come down. I hope you come to the estuary, or you come to your local coastal area, wherever you might be living, and check out these king tides, take those photos, upload those photos, and that way you can participate in this really big photo monitoring project. That'd be great. All right. Thank you, everybody. See you later. Have a wonderful weekend. I think it's going to be chilly again tomorrow, but I think it might be warmer on Sunday. Please stay safe. And when you're outside, wear your mask and try not to be around too many other people. We have a few more weeks, so we got to get through this. Take care.